Hello, everyone. Today we're on Matthew C, lesson 27a. So we are now going to talk about solving systems of equations. So instead of just having one equation on a graph, we're actually going to solve two equations on a graph. Okay, so we're going to be talking about solving systems of equations. So instead of just having one graph, one equation, and graphing that equation, we're actually going to graph two equations. And then somewhere, these lines are going to intersect, and that is going to give us the solution. So this is um, using, so for each pair of equations, graph to estimate. So we're first going to graph to see if we can find the solution that way and estimate the answer. And then we're going to use substitution or elimination to solve for those points of intersection. Okay, so we're going to solve the solutions by graphing, and we're also going to solve the solutions algebraically. We also need our calculator for this one because there are going to be those squares where things are not going to come out very even. So you are going to need your calculator for this lesson. Okay, so let's go ahead and start with the first one. And I'm going to go ahead and solve for y so that I can um, because I just find it so much easier to plug in your points when you've got your equation solved for y. Okay, so I'm going to go ahead and divide by x by both sides. Y equals 12 divided by x. Okay, so let's make a little xy table and figure out how we want to graph this. If I plug in 0 for x, that's no good because um, it will give me an undefined. Remember, I can have 0 in the numerator, but I cannot have 0 in the denominator. So what if I plugged in 1 for x? That's going to give me 12 for y. So I'm not going to do that either. I want them to come out even, and I want all my values less than 8 so they fit on this graph. And let's see. Okay, so what about 2? 2 would work. So I could plug in 2, and then I would get 12 divided by 2 equals 6. Okay, what about 3? Can I plug in 3? So 3 would work as well. 12 divided by 3 is 4. What about what about 4? 12 divided by 4 is going to equal 3. So that gives me another point. That's great. Okay, so I did a great job on the positive values, but what about the negative values? If I plug in -2, that's going to give me -6. And if you can already see the pattern, right? If I plug in -3, that's going to give me -4. And then same thing with -4. Okay, so that looks really good. Now I'm going to go ahead and um, okay, so I see that my second equation is the y equals mx plus b. Those are super simple to graph. So let's just graph this one first, and then we'll graph that one. Okay, I have +2, +6. And then I have +3, +4. And then I have +4, +3. Okay, that looks good. And then I also have -2, -6. And then I have -3, -4. Right, just double checking. -4, -3. Okay. Okay, so that looks pretty good. So I don't know if you can tell, but having some experience doing these a lot can really help. But we do have this kind of arc going on, if that makes sense. We have this kind of arc here. And we could have picked a bigger number to solve for here, but it's not going to come out even. So for just sketching the graph, this is okay. And then we'll see where our values are with this y equals mx plus b line. Remember, that's going to be a line. And we're going to figure out how that looks. And then we'll see about our solutions because we want one of these points to be the same. So some point here and our sum point with our xy table with our line is going to be the same. So graphing y equals mx plus b, super simple. We graph b first, which is our y-intercept. So that is going to be 0, comma b. So in this case, it's 0, comma -5. And then we can just do the slope thing. So our slope is positive. So remember, positive slope goes this way. Man standing on a line. We read left to right. Is he going up or down? And he's going up. So this is a positive line. So we want our line to go this way, and we're always going to go up and over. Our coefficient is 2. So remember, we have to change that to a fraction, 2 over 1. So we're always going to go up 2 over 1, up 2 over 1. If we need to go down, we're going to go down 2, which is in the negative direction, and then over in the negative direction. Okay, so it's helpful to visualize first how we're drawing our line, and then go up and over, and then the opposite, down and over. Okay, 1, 2 over 1, 1, 2 over 1. And normally, if I were just graphing this line, that would be enough. 3 points, that's enough. I'm done. But because we're looking for the intersection of these two graphs, I really want to know, does one of these points intersect with this? So I'm going to keep going. 1, 2 over 1, 1, 2, oh. Okay, so one of the points intersects. Very good. So I'm going to take a note of that point because that one actually intersected with our line. So that's going to be our solution. So this is point 1, 2, 3, 4, 1, 2, 3. Okay, 4, comma 3. So I'm just going to circle it just to give myself a little note, a heads up there. Okay, I haven't intersected this way with the graph, so I'm going to keep going. I'm going to go down, which is a negative, and then negative in this direction. Remember when we were going up and over, we're going positive, positive. So now we're going to go negative, negative. 1, 2 over 1, 1, 2 over 1. So it could intersect there, but I don't know yet. And we won't know that until we graph it algebraically. Now I'm just gonna, you could get a ruler and draw a really nice straight line, and you know what, now that I say that, maybe that's what I'm gonna do right now. Okay, I just have a straight edge here, and I'm just gonna try to draw this line nice and straight, but remember, it's just a sketch. Okay, that looks good. Okay, so certainly right there, it definitely intersects on that point. Okay, so let's solve this algebraically. So we have to do some kind of substitution or elimination. What I see here is I see y equals to this equation. So I'm just going to take this equation, I have a y equals, and I have a y equals for this equation, and I'm just going to set those two equations equal to each other. So I'm going to take 2x minus 5 and set it equal to 12, divide by x. And all I'm doing is I'm just substituting one y for the other. I have y equals 2x minus 5, and I have y equals 12 divided by x. So I'm just taking one y and setting it equal to the other y. So I think I'm going to do it over here. 2x minus 5 is equal to 12 divided by x. Okay, and I'm just going to multiply Remember, I can do lots of things in math. One of the things I can do is I can multiply this x. So I can multiply x over here, and that's fine as long as I also multiply x on this side of the equation. So I get 2x squared minus 5x, and then equals 12. Okay, I'm going to go ahead and subtract over 12 to set it equal to 0. 2x squared minus 5x minus 12 equals 0. Okay, so we have a few options here. We could just do the quadratic. I have A, B, C, and plug it into the quadratic and see what we get. And I'm going to solve by factoring. So I have A times C is 24. So I'm going to come over here, 24, and I'm going to list the factors of 24. Super simple, right? So I have 1 and 24, 2 and 12, 3 times 8, 4 times 6, and 5 is not a factor of 24. So that's it. So which one of these two will add and subtract to get negative 5x? So if I did negative 8 and positive 3, I would get negative 5. Okay, so now we can go ahead and do factor by grouping. So we can do 2x squared, and I'm just splitting up that negative 5x into plus 3x and minus 8x. So I have plus 3x minus 8x minus 12 equals 0. Okay, so I'm going to go ahead and group this first group here. And the only thing I have in common here is x. So I'm going to factor out x, and I'm left with 2x plus 3. And now this second group here, I only have in common, let's see, 4, negative 4. So I'm going to factor out negative 4. Negative 8x divided by negative 4 is positive 2x. And now I'm taking out that negative, so I know this number has to be positive. 12 divided by 4 is 3, equals 0. So now I can group the 2x plus 3. 2x plus 3. So I'm taking that out from this term and this term, and I'm left with x minus 4. Okay, now I can solve for x. So I could take 2x plus 3, set it equal to 0. And I get 2x equals negative 3. X equals negative 3 over 2. So that's one solution. And then I can take this part and set it equal to 0. So x minus 4 equals 0 is x equal to positive 4. Okay, so now I have two possible solutions for x. So this makes sense because if I look at my graph, my solution of x equals to 4, positive 4, is I should get a 3 for y. And then for this part, this is negative 3 over 2. So that's 1.5. So I didn't plug in a point 1.5 at all. But if I look at negative 1.5, look, it does seem that right there, right at x equals negative 1.5, they do cross. So there should be some sort of value for there that is going to satisfy the solution as well. So I have two possible solutions because I have two places where my graphs intersect. Okay, so let's go ahead and we can throw this solution into either place. So it doesn't matter where you want to put it. I'm going to go ahead and put it in here because I have a fraction. And a fraction inside of a fraction can sometimes get messy. And I just don't want to deal with that. I think it's easier to plug it in over here. Okay, so I'm plugging it into the equation y equals 2x minus 5. So I'm going to plug in -3/2. So y equals 2 times -3/2 minus 5. So those 2's cancel. That's very nice. Then I'm left with -3 minus -5, and I get y equal to be -8. Okay, so does this make sense? So my first point is x equals -3/2, comma, -8. So -1.5. So in my estimation, it really wasn't right at -8. It should be down here more, but I should have drawn it a little bit better, but it does look like it could be that. So that's my first solution. And I'm going to go ahead and circle this. All right, second solution, I'm going to plug in 4 into this equation. Y equals 2 times, oops, 4. My brain's thinking ahead. Wanted to write 8 there. 2 times 4 is 8. So 8 minus 5 is 3. So y equals 3. So is that what I have here? Yes. So my first solution, let's write it in our point form over here. Because I'm running out of room. I'm going into the next problem. So I have -3/2, comma, -3/2, comma, -8. That is one solution. My second solution is going to be 4, comma, 3. And that is my final answer. So these problems in Algebra 2 are going to take so much more of your time because there's multiple steps to do these problems, but it is worth it. This is just such a fun way to do math. We first solved the solution by graphing, and then we solved it algebraically. Okay, let's do another one. Okay, I am actually going to move my XY table over here just so that I have kind of more room over here. So my second equation is going to be very easy to do. So I'm just going to go and do that right now. So I'm going to divide by 5, divide by 5. So I have x equals 20 divided by 5 is 4. So x equals 4 is my entire equation for my line. So I need all the values, though x is equal to 4. So x is equal to 4 there. 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 You kind of get my drift, right? This is a vertical line. Super easy to graph, just a vertical line at the value x equal to 4. Okay, great. So I know my line is sketched, not completely straight. All right. And then I have this large equation here. So because it's a little messy, I'm actually going to break my rule and I'm not going to mess with it. I'm not going to separate out. I'm not going to move x to the other side. I'm not going to get y alone at all. I'm just going to plug in points because I just know with all the square roots and everything, it's just going to get a little messy. So let's go ahead and plug in some values and figure out what we want to do. Okay, how about if I plug in x equal to 4? Okay, so you can kind of see why I picked that because 4 minus 4 is equal to 0, and 0 squared is just 0. So let's plug in x equal to 4. I think that's a good place to start. So this would be 0 here. So I still need to figure out what y is. So y minus 4 squared equals 4. Now I am going to need to square root both sides. And when I do that, I get y minus 4 equals plus and minus 2. So plus and minus 2. So now I need to add a 4 over to the other side. So y equals positive 4 plus and minus 2. This is going to give me two solutions. So the first solution is going to be y equals to 4 plus 2. That's going to be 6. And then I was going to box it, but then I realized I don't want to do that quite yet. And then I have y equal to 4 minus 2, which is 2. Okay, so what does this tell me? At the point x is equal to positive 4, I have two solutions. I have the point 4 comma 6 and the point 4 comma 2. Just going to go ahead and erase this line here. Okay. Okay, so I have 4 comma 6 and I have 4 comma 2. Okay, that looks good. So let's pick a different point. Let's pick the point x equals, okay, let's pick the point x equal to 2. Okay, so if I insert 2 into this equation, I get 2 minus 4, which is negative 2. But that's okay because I'm not square rooting it. I'm going to be squaring it. So that's okay so far. So 2 minus 4 is negative 2. Negative 2 squared is positive 4. So I have positive 4 plus this mess, y minus 4 squared equals 4. Okay, so I'm going to subtract 4, subtract this 4 here, subtract that 4, and I get y minus 4 squared is equal to 0. Square root both sides. We can square root 0 because it's not negative, so that works. That's okay. So I get y minus 4 is equal to plus and minus 0. Then I get y is equal to positive 4 plus and minus 0. So plus and minus 0 is just 0, right? So I have y equal to 4. So at the point x equals to 2, I have y equals 4. Now I do not have negative 2 because x is not being squared on its own. If I put in negative 2, I'm going to get a different answer. So it's just, I just get 1 point from this at all. So it feels a little like a letdown because we just are getting 1 point. So 2 comma 4. Now we're going to plug in x equal to 1 because we don't know what this graph is doing yet. So I'm going to plug in x equal to 1. I get 1 minus 4 is negative 3. Negative 3 squared is 9. So then I get this situation. 9 plus y minus 4 squared equals 4. Now I'm going to subtract over 9, and I get y minus 4 squared equals negative 5. And the alarm bells start going off. And I want you to think for a minute why. Why should your alarm bells start going off? Because my next step is to square root both sides. And that would mean I would have a square root under, I would have a negative under my square root. And I cannot do that in math. So that one does not work. Okay, so I picked one so I could show you that there are values that do not work, and you have to recognize when they don't work and why, following the rules of math. Okay, let's pick a nice point that's going to work and to be able to figure out what that is, because I want you to start having an intuition of what points are going to be nicer to pick, because it's going to cut down on the time that you're going to spend doing math. Let's go ahead and graph these 3 points first, and then I think it'll become really clear which point to pick. So I have 4 comma 6. and then 4, comma 2. And then the happy bells should be going off, ding, 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 because these are obviously going to be our solutions, right? Those are where the two graphs are going to meet. I picked, I did points along that line and they intersect with that graph there. So those are going to be our solutions. All right. 2, comma 4. Okay. A lot of these graphs that we've been doing are mirror images. So if you can kind of see what's going on and you notice that both the x and the y are squared, you should notice that this is the equation of a circle and the diameter is 2. So knowing that, where would you pick for your x value to be next? So I know the radius is 2. So because it's the square root of this number. So 1, 2, 1, 2. So this x value is what we should pick because it's going to give us the best number to be able to graph this circle. So 1, 2, 3, 4, 5, 6. So we should pick 6. Plug in 6. 6 minus 4 is 2. Ah, alarm bells should be going off. This is going to be easy for us. 2 squared is 4. Now we just solve, right? I'm just going to follow my steps and I get y equals 4. So 6 comma 4 is going to be our next point. If you didn't have a good intuition about where to pick points, we could pick the point 5, x equal to 5, or we could pick 3. Let's pick 5 and see what happens. 5 minus 4 is 1. 1 squared is 1. So I have 1 plus y minus 4 squared equals 4. I'm going to subtract 1 on both sides. Then I have y minus 4 squared equals 3. And then I square root both sides at this point. And I have y minus 4 equals plus minus root 3. And then I have y equals 4 plus minus root 3. So my y values are going to be 4 plus root 3, which we need our calculator for. 4 plus, and when I put it into the computer, I have to push 3 and then my root. So that's how that works. And it gives me 1.7, and I'm just estimating here, right? And then 4 minus, whoops, all clear. 4 minus 3, and then I have to do the square root, 1.7. We have to do this on our calculator. And so we have to do the root 3 first for this calculator. Every calculator is going to be a little bit different. There's other fancier calculators that you can just plug it in like this and it'll do the equation for you. But this is not a fancy calculator. So we have to put in root 3 first. So 3 square root, that's going to give me a number. And then I need the positive. So that one plus, so plus root 3 plus 4. And then I get 5.7. And then for my next one, I have to do that 3 root thing again. And then I have to make this negative. So I actually need to multiply this by a negative value, which is this. I have to go shift and then this button right there. Does that do it? Equals. Nope. I'm just going to multiply it by -1. Maybe that'll work. 1 negative. Come on. Nope, that didn't work for me. Oh, there we go. So I just found the button that I need. that I needed. So 3 square root, and then I'm going to go ahead and click this button, which will make it negative. Okay, now I can add 4. So negative root 3 plus 4 is what I'm doing. Okay, and that gives me 2.2. So even though these did not come out nice and even, I can plug in the value of 5 for x and I can get these values. So I have 5.7 and 2.2. Okay, so let's go ahead and graph one of these so we can kind of see where it is. We'll graph the 6, 4. X equal to 6, sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So you can see the circle is kind of going like this. And then I'm going to graph these for fun. 5, 5.7. So 5, 1, 2, 3, 4, 5. And it's not quite 5, not quite a half. It's kind of above there, kind of right there. And then 5, 2.2-ish. And same thing, kind of like there. So you can see that the circle is kind of going something like this. Again, if you're an artist, you will draw these graphs so nicely. For me, I just have to sketch it. Okay, so now we can definitely see where we are and what our solutions are, but we really need to solve this algebraically just to check. So it's going to be pretty easy though, because our equation is x equal to 4. So we're just going to take this x equal to 4 and just substitute that into our equation. Okay, so I'm going to plug in 4 into my x value and see what I get. So 4 minus 4 is 0. 0 squared is 0. So I have 0, and I'm not going to write 0 because I don't have to, right? But I can. 0 plus y minus 4 squared equals 4. Okay, so now I can just square root both sides. Square root this side, square root this side. And then I have y minus 4 equals the plus minus 2. And then I have y equals 4 plus minus 2, y equals 6, y equals 2. Okay, pretty simple there, right? We did it up here, so I actually didn't have to write it again, but I was just showing you that would be how you solve it algebraically. So we need to box in our final answer to let our teacher know that we, yes, indeed, did find the final answer. But as a homeschool parent, you would definitely want to check that they have the solution graphed, they have some sort of XY chart to help them graph the circle, and that they did, in fact, solve it algebraically. So those 3 steps do need to be completed. So my final answer is 4, 6 and 4, 2. All right, and that is it. Okay, let's move on to the next problem. These do take a while, so you'll want to budget a little bit more time in your schedule to complete this worksheet this week. Okay, so I have y equals x squared minus 2. Okay, so what kind of graph is that? I'm thinking parabola, right? And then 4x squared plus 9y squared equals 36. I'm thinking, yes, I'm thinking not a circle because the x values and the y values have different coefficients, but it's going to be an ellipse. Okay, so let's go ahead and graph these things. Let's start with a parabola. So I can tell by the negative. Remember, that's going to be opening downward. So let's get an XY table going for this parabola here. Pretty simple. I'm going to plug in 1 for x. So if I plug in 1 for x, that would give me 1 squared equals 1, and then I have a negative hanging out outside the square value. So that gives me negative 1 minus 2. So if I plug in positive 1, I get negative 1 minus 2, which is negative 3. Whenever we're graphing parabolas, remember it's really helpful to find the vertex, and that would be negative b over 2a. And so my b value, remember it's always x squared, x, and then c. So a, b, c. So I have no x, plain x. So my b value is going to be 0. So that tells me, because it's b, negative b over 2a, that tells me that because b is 0, that it's going to be right on this y-axis. So x is going to be 0. When x is 0, that is going to be my vertex. So let's go ahead and solve this. So 0 in for x, and then I get y equals negative 2. So that is going to be my vertex. So I can graph that now to get an idea of how this parabola is shaping up. I have 1, negative 3, 1, 2, 3. And I know parabolas are mirror images on the vertex, so I can just graph this point as well. And let's go ahead and plug in 3. 3 is a good point to plug. So 3 squared is 9. But remember, I have that negative outside the square value. So I have negative 9 minus 2. Oh, that's negative 11. It's kind of a lot. So let's do 2. 2, plug in 2, I get 4. Negative 4 minus 2 is negative 6. So you can go ahead and graph 3, negative 11 if you want, but I'm not going to because that's outside my graph. So 2, negative 6, 1, 2, 3, 4, 5, 6. And then again, the mirror image, I'm just going to graph that. And then we have a nice looking parabola here. So again, if you are more art oriented, your graphs are going to look so much better than mine, but we're just sketching it to see what's happening. Okay, let's go ahead and graph out our ellipse. So we'll just make an XY table for the ellipse. And let's see. Let's go ahead and graph. We're just trying to see what is happening when x equals 0. So I'm going to plug in 0 for x, and then I get 0 squared is 0, 0 times 4 is 0, so that becomes 0. So all I have left is this piece. 9y squared equals 36. And then divided by 9, I have y squared equals. And you know what? I'm not going to reduce that right now because I have y squared equals 36 over 9. I need to square root both sides. Y equals, so 36 square rooted is 6. 9 square rooted is 3. So that gives me 6 over 3 plus or minus, remember, 6 over 3 is 2. So y equals plus minus 2. Okay, so plus minus 2. So I can graph the point 0, 2 and 0, negative 2. So 0, 2, 0, negative. Ooh, look. So that is going to be our solution because it intersects that. That's where it intersects the parabola. So great. So now let's go ahead. I'm wondering, hey, if it's an ellipse, let's see where it crosses the the x-axis. So essentially when y is 0. So if I plug in 0 for y, what do I get for x? So we're going to go ahead and plug in 0 for y, and this term becomes 0, right? So all we have left is 4x squared equals 36. 4x squared equals 36. So divide by 4, divide by 4. Again, I'm noticing that both of those are squares. So I'm actually not going to reduce it right now, but I could. 36 is a math fact, right? So 36 divided by 4 is 9. So I have x squared equal to 9. I square root both sides. I get x equals plus and minus 3. And as long as you can follow the work and you can talk through, feel free to skip as many steps as you want to, as long as you're thinking through it appropriately and you're not making mistakes. But once you start making mistakes, then you probably should show more work. But if you're consistently getting the right answer and you're thinking through all the steps, you don't need to show all of your work. Great, so this means when y is 0, x is plus and minus 3. Plus and negative 3. So let's see, positive 3, 1, 2, 3, 1, 2, 3. And we can just graph the ellipse because we know this is an ellipse. And try to get it nice and rounded like. And again, there's our solution. Let's prove it algebraically. So I have y equal to this. So I'm just going to take this stuff and stick it in for y. Let's see what happens. And I'm afraid I'm going to need more room, but I'll just try to write really small. 4x squared plus 9 times negative x squared minus 2, right? We're going to stick that in for y. Squeeze it in there. Minus x squared and then minus 2 equals 36. I didn't have room on that other piece of paper, so I'm just bringing the fresh piece of paper so I can write them down and figure this one out. So we have 4x squared plus 9y squared equals 36. And then we have y equals negative x squared minus 2. Okay, so actually I'm going to take both of these equations and add and subtract them. Let's see if that gets us anywhere. So I'm just going to rearrange these equations a little bit. So the first one I'm going to write 4x squared plus 9y squared. And then let's leave a blank and then write an equals 36. Okay, let's rewrite this one similarly. So I'm going to want to keep the negative 2 on this side of the equation, but I'm actually going to put the negative x squared on this equation. So I'm going to add over x squared, and it's going to go on this side. So I'm going to write x squared, so this positive x squared, and I'm not going to write anything for the y squared. And so I'm going to write a blank right there, and then I have plus y, and then equals negative 2. So the point is going to be that we want to get rid of this x squared. So what coefficient would this x squared need to be in order for when I add these two equations together, that they give me that these will cancel each other out? So the answer is negative 4. So if this was magically negative 4, then 4 minus 4x squared minus 4x squared would be 0. And that would give me, that would cancel that x out so that I could solve for y. So that is what we're going to do. So I'm going to multiply every single term in this equation by negative 4. So negative 4 times 1 is negative 4. And then negative 4 times 1y is negative 4y, negative 4. And then negative 4 times negative 2 is positive 8. So I can just write 8 right here. Okay, so 4x squared minus 4x squared is 0. I'm not going to write anything. And I have 9y squared. 9y squared. And then 0 plus negative 4y squared is negative 4y. And then equals 36 plus 8. So 36 plus 8 is 44. And I'm going to subtract over 44. So I have 9y squared minus 4y plus 44. 4 equals 0. And I could do factor by grouping, but these are really big numbers. So I think I'm going to go with plugging it into the quadratic just because I think it will be faster than factor by grouping. Usually factoring is much faster than the quadratic, but I have such big numbers, 9 times 44. It's going to take me a while to list all those factors, so I'm just going to plug it into the quadratic. So A equals 9, B equals -4, and then C equals positive 44. So let's write down the quadratic to refresh our memory. This should be memorized. Hopefully you memorized this in Algebra 1, and hopefully it's stuck with you until now because you are going to use it in later math courses. So it's worth knowing, it's worth memorizing. Opposite of B plus and minus square root B squared minus 4AC all over 2A. Let's plug everything in. Opposite of B, which is positive 4, plus and minus B squared, which is 16, minus 4 times A. 4 times 9 is 36. 36 times 44. I'm going to pull out my calculator to do that. 36 times 44 is 1,584. And then all over 2A. 2 times 9 is 18. And I got to make sure I do my negatives. 4 minus 4 times A times C. Oh, and you know what? I made a mistake here. Hopefully you caught it and you didn't make that same mistake. When I brought the positive 44 over here, it should be negative. I should have subtracted it over. So that's negative. So that makes my C negative. So 4AC negative times a negative is a positive. Okay, so remember, this is X. Oh, this is, usually it's X equals, but we are solving for Y here because I have Y squared Y. And so this is Y equals. So that's really important to remember and to recognize. And I have two solutions. I have 4 plus this big mess or 4 minus this big mess. So I can go ahead, let's go ahead and simplify this part and then we'll separate them. So Y equals 4 plus minus. So I have 1,584 plus 16. And that is square rooted. Oh, it's 1,600. So that would make it 40, right? 1,600 square rooted is 40. Yes. Okay. So great. So plus and minus 40 all over 18. Okay, this is looking really good. So 4 plus 40 is 44 over 18, comma, 4 minus 40, which is negative 36 over 18. Okay, so let's go ahead and simplify this. 44 divided by 18 equals 2.4-ish. And then 36 divided by 18 equals negative 2. Okay. So because we could also call this 22 over 9, because I'm plugging this back in somewhere. Oops, sorry. Because I'm plugging this number back in to find X, I'm really going to want to use the real number and not the estimated number. when we're plotting points using the estimated number is fine, but we need to plug it back into a situation. We really need to use the best number available. Okay, so now we're going to take our solutions. This is y equals, and we're going to choose one of these to plug it back into, or we could plug it back into we can't plug it back into here because that won't give us an x value. It will just tell us 0 equals 0. So we need to pick an equation. And they're both a doozy, but this one is certainly more simple. So I'm going to choose the more simple one to use. So I'm going to write y equals negative x squared minus 2. So let's write this down here. Y equals negative x squared minus 2. And I'm going to take 22 over 9 and plug that in for y, because that's what y equals. So 22 divided by 9 equals negative x squared minus 2. I'm going to add the 2 over. So I have 22 over 9 plus 2. And I actually want the fraction because I really want to be I don't want to round quite yet. I only want to round at the final step when I need to plot my points. So I believe I can turn it into this one. Nope. Okay. So I'm just going to have to do it where I do 18 over 9. So 22, 18 over 9 plus 22 over 9. Now I got 18 from 18 over 9 because I'm adding 2 over to the side. So I need to make the denominator the same when I add fractions. So 18 plus 22 is 40. So then I have 40 over 9 equals negative x squared. Okay, so I'm going to divide by negative, and I have negative 40 over 9 equals x squared. And then I'm going to want to take the square root, and I end up in trouble. So much trouble, right? Because I just do not get a real solution. So that is the issue in this case. So that's no real solution. Okay, let's try my second solution. Y equals negative 2. Let's plug that into our formula. Okay, we have some plugging it in right here. So negative 2 equals negative x squared minus 2. So I'm going to add 2 on both sides, so I get 0 equal to negative x squared. And the only solution that makes sense is 0. So I get x equal to 0. Okay, all that to say, all that work, right? To say my solution is y equals negative 2 and x equals 0. So my final answer is 0 comma negative 2, which in this case I found by graphing, because that is where my parabola and my ellipse meet, is 0 comma negative 2. So 0 comma negative 2. So this problem might especially feel frustrating because we did all of this work only to get the solution when we had graphed it. But if I'm the homeschooling parent, I am going to check and make sure you found the no real solution, and you recognize that when you get something like that, you get no real solution. So it's not only important to find the right answer in math, it's important to do the work and to recognize when you don't have a real solution. So that was very tricky. This part up here, knowing how to cancel out the variable and how to solve this. There's a million ways to solve this where you don't get a real solution and you can't find an answer. So this one especially is very tricky. So keep up that stamina and being able to solve these problems. I know these are long, but this is really great practice to solve these really involved math problems. And that's what I would say this um this worksheet especially is a very long and involved math problem, math worksheet. Okay, let's do the next one. So it looks like for this one, if I'm just looking here, okay, so I have it looks like I have a circle here with a radius of 7. So that's quite a large circle of our graph. It's going to take up a large portion of our graph. And then I actually have a hyperbole here. So that is, so all we're going to do is we're going to get some XY tables going. And I don't think this is going to be as involved as the last one, but we'll see. So this circle one, let's graph the circle one. It's so much more simple to graph these circles and ellipse than the hyperbolas. So I plug in 0 for x, and then I just get y squared equals 49. Square root both sides, I get plus minus 7. And if you can't see it just by looking at it and visualize what's going on, feel free to plug in 0, rewrite y squared equals 49, and really figure out in your mind why that works out. Same thing with when we graph ellipse and parabolas, we're going to plug in 0 for x and y. So when y is 0, x squared equals 49. That means x is equal to plus minus 7. Okay, so I just got 4 points right there. 1, 2, 3, 4, 5, 6, 7. So I'm just going to graph all of my points. And then I'm going to try to arc and curve this so it looks pretty much like a circle. And I'm sure I like to go over it a few times just to give myself some grace there. Okay, it looks okay. I'm not an artist, so I'm happy with it. Okay, let's go ahead and graph the hyperbola here. Okay, so we're gonna use our XY table, and I'm gonna get more room for myself. I have my extra paper just in case, but let's plug in 0 for x. What do we get for y? So I have negative 4y squared equals 16. Negative 4y squared equals 16. I have to divide by negative 4. Both sides, I have y squared equals negative, right, 16 divided by negative 4 is negative 4. So alarm bells are going off, right? That's not going to work. Okay, but what if y is 0? Can we get y to be 0 and then see what x is? So go ahead and plug in 0 for y. And I have x squared equals 16. Okay, that's pretty straightforward. X squared equals 16. Now, if I square root both sides, I'm going to get x equals to plus minus 4. So pretty simple there. Plus minus 4. Okay, and I can already graph those. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we can kind of visualize this. We're graphing hyperbolas. So these are going to go this way and this way. So I'm not going to choose any values in here. I'm just going to get a negative value and not be able to graph anything. I'm going to choose something out here, right? So I don't know. Let's choose, let's choose 6. Sounds good. 6 for x. Okay. So if I plug in 6 for x, I'm going to get 36. So 36 minus 4y squared equals 16. I subtract over 36. I get negative 4y squared equals 16 minus 36 is going to be 20. So, and negative, right? I have negative 20. Now I'm going to divide both sides by negative 4. I get y squared equals negative divided by negative is a positive. Woohoo! 20 divided by 4 is 5. And then I need to square root both sides. Square root, y equals plus minus root 5. Okay, this is looking good, but I need to estimate on here what is root 5 so I can graph it appropriately. So clear 5 square root 2.2. So about plus minus 2.2. Okay, so plus minus 2.2. Now I have to think if I plugged in -6, would I get the same thing? Can I get some 2 extra bonus points out of this? So I'm plugging in -6 into my x squared, and hey, look at that. It comes out to positive 36, and I'm in the same situation. So it can be plus minus 6 over there as well. Okay, I've got 4 points. I got an extra 4 points to plot. So let's go ahead and plot all of those points. Positive 6, 1, 2, 3, 4, 5, 6. Positive 2.2, 1, 2-ish right there. Okay, and then just the mirror image of it, 4, 5, 6, and then the mirror image-ish. Okay, and then I can kind of graph these hyperbolas right here, right? I'm going to graph these hyperbolas. Okay, so I can tell what's going on, right? I'm actually going to have 4 solutions. 1, 2, 3, 4. But I've just sketched the graph. None of my points that I plotted lined up right. So I'm going to have to solve this algebraically to really find our solution. And again, I'm running out of room, and I have an inkling that this is going to take a bit of work. But I see that I have x squared and x squared. So if I just multiply one of these equations by -1, then it's going to cancel pretty well, and I'm going to be left with an equation I can solve. So I think I'm going to take that route. Another thing I could do is, yeah, I think that's just going to be easiest. So, I'm trying to see what I want to do. I'm going to start off on this paper to see if I can squeeze it on. X squared minus 4y squared equals 16. And then I'm going to multiply by -1. So I'm going to get negative x squared negative minus y squared equals -49. Negative x squared minus y squared equals -49. Okay, so we're just going to add those together. And then x squared minus x squared goes to 0. Negative 4y squared minus y squared is -5y squared. And then 16 minus 49 is -33. Okay, this is looking pretty promising here. So I'm going to divide by -5 on both sides. So y squared equals, then I have a negative divided by a negative, which is a positive 33 divided by 5 is 6.6. And then I'm going to need to square root both sides. I have y equals plus minus 6.6 square rooted, which is about 2.5-ish. I could round to 2.6, but I'm just, well, we do kind of want to be, I'm not graphing, so I do want to be really exact. So I'm actually going to go with, I'm actually going to go with square root of 33 divided by 5 because we still have to plug this in to one of these to solve for x, and I just want to be as exact as I can, or else it's going to mess everything up. So here's the exact number. It's messy, it's not nice, but that's okay. But I still do want to estimate for later purposes. So it's about 2.5-ish, plus and minus, right? Okay, I can already check. Does that make sense if y is equal to plus and minus 2.5? So y, 1, 2.5. Ooh, just about right. And just about, yeah. So that does make sense. So I'm on the right track. But now I'm going to take this messy number and I'm going to plug it in. I think I'm going to use this equation because it looks more simple. So I have x squared plus this messy thing, the square root of 33 over 5 squared is just 33 over 5, right? So I can just write 33 over 5 equals 49. This is not going to be nice at all. So I have to take 33 over 5 and subtract it from 49. So 49 minus 33 divided by 5. Okay, 49 minus 6.6. I'm just checking, make sure that I'm putting everything in really, really well. So 42.4. So x squared does equal 42.4. And oops, I wrote the wrong number. I said it right. I just wrote it wrong. 42.4. I'm going to go ahead and square root that side, square root this side. So x equals, I'm still good. Square root that number and plus and minus 6.5-ish, right? This is an estimation. So does that make sense? So the x is going to be 6.5-ish. And then 1, 2, 3, 4, 5, 6. So yeah, ish. Yeah, that sounds about right. So my exact number is going to be plus or minus 42.4. So this is really messy and not nice, but they're both plus minus, so that does give me 4 points. So plus minus square root 33 over 5, comma, oh, that's my y. Someone stop me when I make a mistake. Okay. Plus minus x square root of 42.4, comma, plus minus square root of 33 over 5. I know it's messy. 4 possible solutions. So because I wrote it like this, I really want to tell my teacher that I understand there's 4 possible solutions. So 4 possible solutions. And as a homeschool teacher, I would absolutely take that. Another option is to list all 4 points. So you would list positive square root of 42.4, comma, positive square root of 33.5, and then positive 42.4, comma, positive 33 root 5. So if I didn't write 4 possible solutions, I'm not sure I would accept it. I would definitely ask my student, hey, do you know how many possible solutions there are? They could point to their graph and say, yes, there's 4, 1, 2, 3, 4, or they could write it down. All right, so that one was easier than the last one, but it still takes a lot of work to get where we're going. Okay, I have a feeling the Math-UC sandwich some really hefty ones, and then these are going to be easier. I can tell these are parabolas because the x is not squared and just I have one squared variable. So yay! No circles or ellipses, no hyperbolas. This is going to be easier. So let's plot some points and get this going. So I'm going to do the first one first. I have x equal to 2y squared minus 5. And I'm just going to leave it like that. I think it's fine. Yeah, it's going to be okay. So, I'm going to plug in zeros. I'm going to plug in values for y and see what I get for x. So let's go ahead and plug in 0. If I plug in 0 for y, I get 2 times 0 is 0. And so I'm just left with -5. If I plug in 1 for y, 1 squared, so I'm plugging 1. 1 squared is 1, 2 times 1 is 2, 2 minus 5 is -3. And then let's go ahead and plug in a bigger value. It's going to get bigger fast though. Yeah, let's try 4. I really want to try 4. 4 squared is 16. 2 times 16. Oh, that's going to get really big. I take it back. Let's try 3. I think 3 might work. 3 squared is 9. 9 times 2 is 18. 18 minus 5 is 13. Oh, that's too big as well. So let's stick with 2, I guess. I really wanted to do like a bigger number, but it's okay. It's fine. 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. It's much better. Now I can also recognize that if I plug in -1, then I'm going to get the same thing. So I can do plus minus 1, plus minus 2. That gives me a few more points. -5, comma 0. -5, comma 0. And then I have -3, 1 and -1. And then I have positive. Did I do that correctly? I think so. Yeah, +3 in the x direction, -2. Did I do those right? Now I'm second guessing myself here, but yes, I think this is right. Let's see. I plugged in 1, right? Okay. Just reminding myself. Okay. 3 in the x direction, +2 in the y direction. 1, 2, 3, 1, 2. Okay. Okay, I was second guessing myself a little bit there, but this looks really good. This looks like a great parabola. And if x was the variable that was squared, remember it would be up and down, but because y is the variable that's squared, it's on its side. Okay, so there we are. And let's go ahead and do the second parabola. So another XY table is what I need. And I'm going to be plugging in values for Y and seeing what I get for X. And it plays with my mind a little bit. So I often second guess myself when I do this. So I plug in 0 for Y and I get -1 for X. And let's go ahead and plug in 1 for Y. It's going to get big fast. So I'm probably going to do 1 and 2 just like here. So 1 squared is 1. And then I'm left with -2 times 1. So -2 minus 1 is -3. And ooh, and look, did you see that? All right, just hint there. And then if I plug in -1, I am going to get the same answer, so I can get an extra point for free there. So let's go ahead and plug in 2. 2 squared is 4. 4 times -2 is -8. -8 minus 1 is -9. And if I plug in -2, am I going to get the same thing? And the answer is yes. So I get another point for free. So let's go ahead and graph this. -1, comma 0. -3, +1. And notice that's the same point. Hint, hint. -3, -1. Aha. And then I have -9 in the x direction, which is this over here. And then a +-2. Okay, let's go ahead and graph. What is this parabola? It looks something like that, but graphically, we did have overlapping points, so we exactly know what our solution should be. So what I'm going to do is I'm just going to add these because I recognize that 2y squared and negative 2y squared. So if I add those together, I get 0. So that cancels out that variable, making it very easy for me to solve for x. So x equals 2y squared minus 5, and then x equals negative 2y squared minus 1. So we can go ahead and add them together. X plus x is 2x equals 2y squared minus 2y squared is 0, yay. And then negative 5 minus 1 is negative 6. Divide both sides by 2, x equals negative 3. So I know that x equals negative 3 is going to be my solution. And now I just need to take this and plug it in for y, plug it in for x and solve for y, which we were always plugging in y and solving for x. So I'm going to go ahead and do that math. I'm going to pick the first equation, and it does not matter which equation you pick. So I'm going to have negative 3 equals 2y squared minus 5. So I'm going to go ahead and add 5. That gives me positive 2. Divide by 2. So I get 1 equals y squared. And then square root both sides, super easy. Then I get plus and minus 1 equals y. So my final solution is, so there's two ways to do this. You could either write negative 3 comma plus minus 1 and then say 2 possible solutions, or you could just write out negative 3 comma positive 1 and negative 3 comma negative 1, and those are my solutions. Now, if you just wrote negative 3 plus minus 1 without doing anything else, then I, as the homeschool parent, would ask my child if they know how many solutions there are. And if they said 1, then you would want to reteach about how to find all of the possible solutions. Okay, last one. This assignment is going really long, so keep going. Do this over several days if you need to. Okay, so I've got a line here, and I've got a parabola on a regular parabola. So it's positive coefficient in the x direction, so it's going to be pointing up. And this looks like it's really not too bad. So let's go ahead and graph the line first. That's going to be the easiest thing to do. So I'm going to start with my 0, comma b, which is my 0, comma positive 4. And then my coefficient on the x, remember, it's not 0, it's 1. So that's really important in math. And turning 1 into a fraction is 1 over 1. So it's just up 1 over 1, up 1 over 1. It's a positive slope. So remember, it's going this way. Man standing on a line, and we read from right to left. He travels from right. Sorry, we read from left. This is left to right, and then he travels from left to right. So is he going up or down? He's going up. So this is a positive slope. Up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. And if you can use a straight edge, or you can just kind of guesstimate where we're going here. This looks really good. Okay, that's a great sketch of the graph. Okay, let's go ahead and graph this parabola. This doesn't look so bad. Let's make an XY table and graph this thing. Okay, so I'm going to pick some points to make this come out really nice numbers. So we can pick 0 first. That is really helpful. 0, comma, if I plug in 0, I'm left with 3. If I plug in, I don't want any fractions. So I'm going to plug in 2, because if I plugged in 1, I would end up with a fraction. So let's plug in plus minus 2, right? We can do that at the same time. 2 squared is 4. 4 divided by 2 is 2. 2 plus 3 is 5. So I get 5. Remember, I don't get plus minus 5 because my y value is not being squared in this case. So it's really important to know when I can do plus minus and when I can't. Okay, well, 5 isn't too bad, but this is going to get big really quick. So maybe we could do 3. Let's see. Oh, but that's going to give me a fraction. So I don't want to do 3. I know 4 is going to give me probably a big number. Maybe not. It is divided by 2, so it's okay. I'm going to plug in plus minus 4. 4 squared is 16. 16 divided by 2 is 8. 8 plus 3 is 11. Little bit of a big number, but it's okay. I'm going to graph it anyway. 0, 3, 1, 2, 3, plus minus 2, 5, and then negative 2. Okay, and then plus minus 4. And it's off my graph a little bit, but that's okay. Okay, so nice little parabola here. There we go. Okay, so you can see that this oh, I drew it wrong. I picked the wrong point. Okay, there we go. So I can't really tell by graphing where exactly it crosses the line, but it looks to be somewhere here and somewhere here. So let's go ahead and solve these equations algebraically. I think we're going to stick with, we could just add these together like before, but there's a fraction here, so I don't really want to do that. So I'm just going to say, because I have y equals for both equations, I'm just going to take this equation and set it equal to this equation. Let's see what we get. We have x plus 4 equals 1/2 x squared plus 3. Okay, so I want to get rid of the fraction, so I'm just going to multiply every term in this equation by 2. So I have 2x plus 8 equals, and then 2 divided by 2 is 1, so I just have x squared, and then plus 6. Okay, that looks good. Let's move everything over to one side and set it equal to 0. I'm gonna move everything over here, So I have 0 equals x squared minus 2x. And then I'm going to subtract 8. So positive 6 minus 8 is negative 2. Okay, not too bad. I'm going to see if I can factor this because factoring is often faster and I don't have big numbers. So 1 times 2 is 2. List all factors of 2. There's only 1. So can I add or subtract 2 to get negative 2? And the answer is no. I could get 1. I can get 3. And I can't get negative 2. So I have to plug it into the quadratic. I'm just double checking that that is correct. And that is correct. We have to plug it into the quadratic. So A equals 1, B equals negative 2, and C equals negative 2. Okay. Thought I was going to be able to factor this, but nope. Opposite of B, so 2 plus and minus B squared. Negative 2 squared is 4. Minus 4AC. Negative times a negative is a positive. Okay, so 4 times 1 is 4. 4 times 2 is 8. Oh, no negatives, so we're doing good here. All over 2A, so 2 times 1 is 2. Okay, these numbers actually aren't that big, so this is going really well. 2 plus or minus square root of 12 over 2. Okay, not too bad so far. 12 is not a square, but there's a factor of 12 that is a square. So that's 4 times 3. You square root 4 and you get 2. So the square root of 12 is 2 root 3. So that's a review from Algebra 1. 2 plus and minus 2 root 3 divided by 2. So remember, we're solving for x here. So this is x equals. So I'm at the bottom of my paper here. I'm just going to write it over here. So I have x, or I could write it over here. So I have x equal to, I could just divide everything by 2. So I have 1 plus or minus root 3. And that would be my final answer, but I'm going to estimate it just so I can check my answers on the graph. So x is approximately, so I have to do root 3 first. Let's see. So root 3 first, and then I have 1 plus root 3, so I'm just going to add 1, and 2.7, and then I need to do root 3 again first, make it negative, and then add 1 again. And then I have negative 0.7. Okay, so does that make sense according to my graph? So 2.7, 1, 2, yeah, look, so it's going here. It's either hitting at 3 or right. So at 3 or right before 3. And then my negative 0.7, it's hitting definitely before 1. So that looks like it could be negative 0.7. So that's good news. I'm going to take my exact measurement and plug it in for y. So sure, this is going to look a little messy, but bear with me here. So I'm going to use the simpler equation. I'm thinking, yeah, that's what I want to do. You can use either equation. Y equals x. So x is 1 plus or minus root 3, and then plus 4 plus 4. So y equals, we're just going to take the whole numbers, combine like terms, right? So 1 plus 4 is 5. 5 plus minus root 3. So what is y approximately equal to? So we can double check with our graph. So we have to do root 3 first, and then add 5. So 6.7, comma, and then we have 5, oh, do root 3 first, sorry, and then make it negative, and then add 5 again. What do we get? 3.2. Okay, but it's important, right? We only have 2 solutions. We don't have 4 solutions, right? This is super important to understand how many solutions we have. So on our graph, we only have 2 places where this graph intersects. So I have to know which numbers go with which so I can write down my answer appropriately. So let's see. 2.7. So the case of 1 plus root 3, what does that pair up with? So 1 plus root 3 is 2.7. So 2.7. 2 and let's see, 2.7. Yeah, 2.7 right here. So that would match up with 1, 2, 3, 4, 5, 6, and some more. So that would match up with my 6.7. So that matches up with 5 plus root 3. Okay. Now my second case, my x equal to 1 minus root 3. 1 minus root 3. Does that match up with 5 minus root 3? So negative 0.7, about here, is that approximately 3.2? 1, 2, 3. Yes. Yes, that matches up really good. So 5 minus root 3. Now, as the homeschool teacher, if you notice that your child writes 1 plus or minus root 3, comma, 5 plus or minus root 3, that would be marked wrong because you are telling me there's 4 possible solutions. That's what that answer means. So in this case, you do have to separate it and tell me exactly which one goes with which. Because in some cases, in this case, it's the positives go with the positives and the negatives go with the negatives. But in other cases, it could be different. So you have to show me that you understand which points exactly are the solutions. Okay, super fun. I particularly enjoyed the last one. I hope you did too. And I hope to see you next time when we do these, when we meet again to do 28A. All right, bye.